Hello everybody and welcome to the remote presentation of our paper, A Recommender System for Investing in Early Stage Enterprises. The authors of the paper are my colleague Johannes Luef, me, Christian Ohrfandl, Dimitris Sacharidis and Hannes Werthner. The paper itself was derived from 2 diploma theses by Johannes and me, who are both the main authors and contributed equally to the paper. We hope you are and will stay healthy during the currently active COVID-19 worldwide crisis and wish you a pleasant 20-minute journey through our paper. Before we start our endeavor, we want to give you a brief overview about the remainder of the presentation. First, we'll introduce you to the problem definition and research questions. Afterwards, we inform you about the 3 main topics of this paper, namely the requirements analysis of venture valuation and investment decision-making approaches by investors, the modeling of the recommendation algorithms, and finally, the evaluation of the recommender system. This paper discusses the design, implementation, and evaluation of a recommender system that assists investors looking to fund enterprises in their early stage. As this application domain is relatively new for a recommender system, we first need to understand the decision processes of investors and set to investigate the first research question. How can decision-making requirements and investor behavior be quantified? Based on the outcomes of this requirements analysis, we explore the second research question. Which recommendation algorithms are appropriate in the domain of enterprise investment? Finally, based on the identified and modeled recommendation algorithms, the third research question arises naturally. Which recommendation algorithm is most effective in the domain of enterprise investment? To design a recommender system for investments in early-stage enterprises, we first need to understand the needs and expectations of the end users, the investors. The following slides present the results of our requirements analysis that includes qualitative and quantitative research. In the first phase, we conducted a qualitative expert interview to collect expert knowledge on decision-making criteria and enterprise valuation methods utilized by the investors in the domain of early-stage enterprise investment. The results of this study, together with our literature review, informed the quantitative study. We conducted a strongly structured interview where a questionnaire with 39 various typed questions is compiled beforehand following the literature review and the pretest. The goal is to learn about investment decision criteria and expectations from a recommendation platform. The interview was designed to run for 90 to 120 minutes, and 28 prominent investors from the DACH region, meaning Germany, Austria, and Switzerland, were invited. In the end, we conducted in-person interviews with 6 investors. The main reasons for the low response rate was reluctance to participate, in spite of long networking efforts, and simply lack of time for such an extended interview. However, we gained insights into the decision criteria for investment in early-stage enterprises and collected investors' expectations from a recommendation platform. In the second phase of our requirements analysis, based on the aforementioned findings, we conducted a quantitative study in order to guide us in the design of the recommender system. Specifically, we crafted a questionnaire containing 7 questions, 6 of which were to be answered on a Likert 1 to 5 scale, and 1 was dichotomous, meaning yes or no. Overall, we contacted 47 investors and got responses from 25. As an example, we show you the results of one of the most important questions. Upon which criteria do you decide whether to invest in an early-stage enterprise? Participants were asked to rate 10 criteria options on a 5-point scale, ranging from unimportant to important. To assess the practicability of the results, we performed a Wilcoxon-signed rank test to investigate whether the opinion that an option is rather important or important is statistically significant at a 97.5 level, compared to the null hypothesis of it being neutral. The test is positive for the following 5 options: recommendations, for example, by investors, industry sector, experience of entrepreneurs, return on investment versus risk, and market research. In what follows from the requirements analysis, we concluded 5 specific requirements identified from our qualitative and quantitative studies. R1. The system should support the scorecard and Berker's valuation methods and also allow for the retrieval of the valuations of an enterprise. R2. For each enterprise, the system should present information about its team, product, and market sector. R3. The system should allow investors to build a detailed profile that captures their interests and their relative importance and support the retrieval of best matching enterprises. R4. The recommender should draw upon historical investment behavior when making recommendations. R5. The system should provide the option to consider the opinions of other investors when making recommendations. Concluding the requirements analysis section, we want to present the recommender system next, which design is based on the requirements outlined previously. First, we present the main entities of the system, how they interact and show that they comply with requirements R1 to R4. Then we discuss various recommendation approaches and how they support requirements R3 to R5. Early-stage enterprises are to be recommended and thus correspond to items in the recommender system's parlance. Enterprises are described by their content, certain attributes that were found to be highly important in our requirements analysis. An enterprise is managed by a team of entrepreneurs. This user role is also tasked with maintaining the entry in the system. Another user role is that of a valuator that creates valuations for enterprises using either the scorecard or Berker's methods. This complies with requirement R1. Investors are the entities receiving recommendations and are thus also called users. The system allows users to build their investor profile but also collects user feedback in terms of user item interactions. To comply with requirement R3, the investor profile contains, among others, the following information: market sectors, product description, and investment amount. Requirement R4 mandates that past investor behavior is an important source of information. As investors interact with the system, they provide feedback that a recommender can build upon. We collect 3 types of signals presented in increasing strength. An investor may click on an enterprise, seeing all information available in the system. An investor may express interest on an enterprise by liking it. And of course, an investor may also specify that she has already invested in an enterprise. Next, we want to present the recommendation algorithms we identified for being used in the recommender. Our requirements analysis found that there are different ways in which investors decide to choose an enterprise to invest in. Therefore, instead of proposing a single recommendation list, we choose to go with a Netflix-style presentation of recommendations where there are multiple recommendation lists, each produced by a different recommendation engine. In what follows, we describe the 5 engines employed. The knowledge-based recommender is based solely on the investor profile and the enterprise description alone, and thus complies with requirement R3. The algorithm essentially matches enterprises, based on their description, to investors using a combination of filters and so-called preferences. Filters come directly from the attribute values specified in the investor profile and act as hard constraints that an enterprise needs to satisfy in order to be recommendable or relevant. Preferences are specified on the same attributes, but act as soft constraints that induce an ordering on the attribute domain. For example, investors might prefer enterprises with high valuation amounts. The collaborative filtering approach is based solely on the historical behavior of all investors and thus satisfies requirement R5. We implement neighborhood methods based on either user-investor or item-enterprise similarities. The content-based recommender is based on the enterprise descriptions and the investor's historical behavior, and thus complies with requirement R4. Briefly, the algorithm creates a virtual enterprise based on the investor's history and then matches every enterprise to it. The social trust or social-based recommendation algorithm is also based on the historical behavior of all investors and offers a different interpretation of requirement R5. Specifically, it corresponds to a trust-aware strategy and materializes the inner circle of trust that investors mentioned in our qualitative study. The final recommendation strategy, the hybrid recommender, attempts to reconcile requirements R4 and R5, making use of the historical behavior and the profiles of all investors. The hybrid recommender is also a variant of user-based collaborative filtering, with the key difference lying in the similarity function employed. Two users are similar if they have similar investor profiles. Concluding the modeling of the recommender system, we now want to proceed to the evaluation of the recommendation algorithms. Specifically, we seek to answer two questions. How different are the recommendations produced by the various algorithms, and which recommendation algorithm is the most effective? We chose to perform an offline experiment as the system is still at a prototype stage. Given the limited availability of end users, the investors, we chose to compile a small dataset to run experiments on by collecting all necessary information from investors using a questionnaire. An important step before collecting investor information is to create a small manageable list of candidate enterprises for investment. We considered several existing early-stage enterprises that are active in the DACH region and select 10 of them so as to have a balanced mix of different products, life cycles, market sectors, known or unknown valuations, management team size, and establishment date. The next step is to collect from investors all necessary information, meaning investor profiles and historical behavior that is required by the system in order to generate investment recommendations based on the various algorithms. We design a questionnaire with 11 questions that requires a maximum participation time of 15 minutes. In the end, 35 out of 68 investors participated. In what follows, we describe the questions. The first 9 questions concern the investor's profile, question 10 concerns the inner circle of trust, while the last, question 11, is used to create their historical investment record. The raw data collected by the questionnaire has to be processed for training and evaluating the recommender algorithms. We use the answers to question 1 to question 9 to create the investor profiles, question 10 to define the follow relationships, and question 11 to define the historical investor-enterprise interactions, which we then partition into a train and test set. We measure the correlation across the recommendation lists and the ranking accuracy of the recommendation algorithms. Correlation is measured by Spearman rank correlation that measures the strength of association between two lists and its direction. It takes values between -1 and 1, where the higher values, the more similar the lists are. Ranking accuracy is measured by precision at k, which simply counts the number of relevant items, the early-stage enterprises, among the top k, and by mean average position at k and normalized discounted cumulative gain at k, where the position of the relevant items in the ranked list discounts their relevance. We vary k from 1 to 3. All ranking accuracy metrics range from 0 to 1, with higher values preferred. The present table reports the Spearman rank correlation for every pair of recommendation algorithms. Overall, we report very weak correlations except 2 cases. The content-based CB and knowledge-based KB recommenders exhibit weak rank correlation, given that they both depend on the content of the items. We also identify a moderate correlation between the knowledge-based KB and the hybrid HR recommenders, which is explained by the fact that HR is based on KB, as it explicitly uses the rankings that KB produces to define similarities between investors. This table presents the ranking accuracy metrics of all methods. The most interesting aspects are derived from the fact that user-based approaches, such as collaborative filtering, CFUB, and social-based recommendations, SB, perform the best in terms of ranking accuracy, with the latter outperforming the former. This observation essentially corroborates the fact that investors tend to think alike. Moreover, explicit trust relationships among investors are more trustworthy than implicit investor similarity relationships extracted from past behavior. An important conclusion of this study is that there seem to exist circles of trust among investors, and capturing them explicitly or implicitly plays a key role in improving the ranking accuracy of the recommendation list. We also want to discuss some limitations of the current work. Due to general lack of availability from the investors, we could only simulate an offline experimental evaluation with a rather limited number of participants. This in turn dramatically reduces the number of user item interactions we can collect. We also want to note that the low ranking accuracy of the knowledge-based KB recommender, and thus also the HR as well, could be attributed to potential discrepancies in the collected data. Moreover, another limitation is that the investors that participated in our study are all from a single geographical area. Similarly, the selected early-stage enterprises all come from the same geographical area. Thus, there is the risk of selection bias in the collected data. Ultimately, we want to present a brief conclusion about our work. This paper presented a design study of recommendation approaches in the domain of investing in early-stage enterprises. A detailed requirements analysis found specific desiderata for a system, including the need to respect investor profiles, learn from past decisions, and propagate trust among investors. An evaluation scenario demonstrates that simple collaborative filtering approaches, and especially a trust-based one, is more effective than knowledge and content-based approaches. Future research may concentrate on popularizing data and thus may enable an entry point for other scientific evaluation approaches. We want to thank you for your attention and hope that we were able to give you an overview of our paper. If you have any questions, please do not hesitate to contact us. Goodbye.